look at that. Again, session 4. And let's go into our curriculum and click on that. It takes us to our curriculum page, and I'm going to expand it so we can talk about what we need to achieve here. So, talking about those services, can anybody remind me what are the 3 key compute cloud services?
You already.
Yes, go for it.
You have compute, network, and storage.
Yes, compute, networking, and storage. So we're going to start with compute, right? Compute again, think about your hard drive or think about your computer. So obviously here's a schedule of what we're looking at. We are currently on the 11th of March. And just as a friendly reminder, tomorrow we're going to have daylight savings time. I don't know if it's Saturday. No. I think it's Saturday breaking Sunday or it's Sunday breaking Monday. I can't remember. Does anybody remember?
Today night, breaking tomorrow Sunday.
Or it's today night breaking tomorrow Sunday. So we're still going to maintain our 2 p.m. Eastern time. So for those that are connecting from Cameroon, you're actually going to be 1 hour ahead. So, but I'll send out a reminder also before class starts. All right. So this is a good reminder for me. So we're still going to maintain our 2 p.m. time. That said, let's carry on. What are we going to talk about with compute services? So compute services, we're going to learn about 3 main things. Amongst other things, we'll learn about virtual machines, we'll learn about containers, and we'll learn about Azure functions. I know we talked about it. Someone asked about it last week, and I promise that we'll get to it this week. But those are the 3 main things we'll talk about. But as usual, we have outcomes. We have things we need to achieve by the end of this class. Just like the last 1 hour, we were able to achieve those things. I'll see if I can run through this in 30 minutes. First, we'll talk about the compute types, virtual machines, containers, functions. We'll also talk about the different options in a virtual machine, whether it's the scale sets, availability sets, or the virtual desktop. And then we'll also talk about what are some of the resources required within your virtual machine, which has to do with the size, the disk capacity, and the networking options. And then finally, we'll talk about other options if you want to host applications. Naturally, you can host applications in your virtual machine, you can host them in your container, you can also host them in web apps, and so on and so forth, which we'll talk. All right, so let's dive right in. First, virtual machines sounds a little bit cumbersome, but think about that discussion we had again about hardware and software. At the end of the day, if you have a software or an application that you want to do a particular thing, think about your cell phone. On your cell phone, you want to have a calculator on your cell phone. That calculator is an application. Or if you want to have Facebook on your cell phone, Facebook is an application. Facebook needs to be installed on top of an operating system. So depending on what type of machine you're using, if you're using a cell phone, that's Android operating system. If it's Apple, iOS. If you are installing it on your computer at home, then it could be Windows, Linux, and so on and so forth. Okay. Normally we have our hardware, the physical hardware that has CPU, which is the central processing unit, not very smart, just very fast. So it has all these instructions that it processes 1,000,000 times a second, which we cannot think at that speed. So it has all these things, and that makes up part of the hardware on the motherboard. You also have a RAM. The RAM is your memory, right? Where you have cache and all that being stored, instant memory. You also have a disk. The disk could be a hard disk, HDD, it could be SSD, a solid state disk, and so on and so forth. Those are all the different resources that make up your hardware. Okay. So now when you look at this, you usually have one computer, one operating system, and a bunch of applications running on it. But that was way back when we started using computers. Later on, we realized it was better for us to create a virtual machine. So you have your one hardware And then on top of that hardware, you have a hypervisor. On that hypervisor, you can decide and allocate. Say, I'm going to allocate this amount of CPU, this amount of disk space, this amount of RAM to run, say, Linux operating system. Allocate another one to run Windows operating system, and allocate another one to run maybe another version of Linux. Okay, so that's how virtual machines got created. That will be a virtual machine on your computer. But Azure Virtual Machines is when you create these virtual machines on the cloud. We have seen what a data center looks like. Now you're saying that on that data center or in that data center on the servers, give me a section of it and create me a virtual machine out of that, just like we do on our physical computer. So does that make sense to everyone? On that virtual machine there. Yes, Gilbert, you got a question?
Yes, I'm trying to understand the virtual machine. So from what you've said, it's like it's the same as the physical machine, which
Yes,
has a RAM and a storage and interconnected to network. So
yes.
the same way we have the physical machine, the same way the virtual machine also will be. If I've gotten you well.
Yes, the same way the virtual machine would be. So for instance, think about you have a big piece of land. On
Mhm.
that big piece of land, you want to build your house on there. Just building that house, you'll probably be wasting most of that land, right? So you
Yes.
decide now that you're going to allocate one piece of that land or a part of that land for someone else to build a school, another part of that land for someone else to build a restaurant, another part of that land for someone else to build a hospital. So you're allocating all separate resources for particular operating systems. And then you have in the school, they can teach mm, economics or teach computer science or teach a particular language. Those are all different softwares that are being built on that operating system. In the hospital, you can have an emergency ward, you can have a maternity, you can have other surgery areas. Those are all different applications within that operating system of the school. But then you still have your hardware. Does that make sense?
Yes, yes, makes sense.
Yeah, so that's how you virtualize. Again, in this case, it's still not virtual, it's actual, but that's how you create or allocate particular resources to have a virtual machine. So in that case, that's basically doing it on a physical machine. But when you do it on the cloud, it becomes beneficial in many ways because you can create skill sets. So think about you have a cup that you want to pour water in, right? When you pour water in the cup, when it starts filling up, it gets to 90%, you're running out of capacity. But imagine that you have exactly that same cup available for you so that you can pour half of it and then now you can have more capacity to be able to adjust. So scale sets is when you have identical virtual machines that are created for you automatically. Because you're on the cloud, you have that scalability, right? So if you have more traffic coming to your software or you need more resources, you go ahead and create an identical set and then you scale automatically. That's how you create a scale set. And all of this is centrally managed and configured and updated for you. So you don't have to go and individually manage each one of those virtual machines. That will be the case for you if you had to do it physically. I don't know if anyone here has tried creating a virtual machine physically. If you went to a Linux class, maybe you have tried doing that. You realize that you create a virtual machine and say, I need just this amount of CPU, just this amount of RAM. You start adding applications and you start running out of space. Now you have to go and expand it yourself and you don't know how much you expand. Tomorrow you still need to add more applications. It becomes tedious to manage it that way. On the cloud, if you create skill sets, it automatically scales it out for you and the identical CPU, RAM, and disk is out there for you to be able to use. Okay. So that's for skill sets. Availability sets is different because it helps you have that high availability. We talked about those two things, right? Scalability and high availability on the cloud. Availability sets is such that if you want one area to be updated or want to have varied power on network, you are able to have different levels of these resources available to you. If one user or one set of users want a particular update, then you can deploy it to one. And if it's affecting that one and it goes down, you still have the older update that you can back up to be able to utilize it. Okay. So having those availability sets also help you to be able to be more resilient in giving your or in providing your services. Now, when do you want to use virtual machines? Yes, question.
Yeah, Victor, I just want to ask when, of course, in the realm of virtual machines, let's say when you have your laptop, for example, which is almost like your brain, that's the CPU, everything, you know what I mean? Then you connect the laptop now to a docking station, and you have like an HDMI cable that it connects the that plugs into the docking station into another monitor. So now you have basically two computers. You know what I mean? You have a monitor and you have your laptop, and you are able to shuttle between the laptop and the monitor. You can easily transfer, like carrying a page from the monitor to the laptop and vice versa. Is that, let's say that monitor, is that some kind of a virtual machine?
Very, very good question. Very good question. Does anybody have an answer to this? Does anybody want to participate and tell us if they think yes, Mr. Adolf?
That is not a virtual machine. That would just be like you're using a relay just to use that like a different interface to like enable you have share screens. But yeah, like a virtual machine is like it has an operating system embedded in it.
Exactly. So that's a very good way of putting it. I like how you use the word operating system. The other thing to add to it, Fred, is that we have to remember again, hardware, anything that is tangible, anything that you can touch, that is hardware. So when you add another screen, a screen is an output device. A screen is a hardware. Just like your keyboard is a software, your keyboard is an input device. Your mouse is a hardware, your mouse is an input device. Your microphone is also a hardware, your microphone is an input device. Your speaker is a hardware, your speaker is an output device, just like your screen. So you can add more speakers and add more screens. You're just adding hardware. But when you add an operating system within your hardware, you're not adding hardware, you're using the same hardware that you have altogether, but you're using a section or allocating, let me use that word, you're allocating a section of those resources to make a virtual machine. As you see at the bottom here, the resources that you need to make up a virtual machine are usually your RAM. You dedicate an amount of size from your RAM. Maybe your computer has 200 gigabytes. You can dedicate 15 or 20 gigabytes to create a particular operating system. You also dedicate storage, and then you get to set up its network, how you want that to be connected to the rest of the machine. So you have to set up if it has a public IP, if it has a port, which we'll talk about networking next week. Does that answer your question?
Okay, it helps.
Very good. I love that question. It's always good to ask your questions and clear your doubts. Okay. So yes, now we've talked about virtual machines, skill sets, and availability skills. But when do you want to use a virtual machine? Let's say, for instance, I created my application. I want to see how my application looks on a particular machine. I can go ahead and use it for testing and development. So developers can create virtual machine, create a virtual machine that is Android, create a virtual machine that's Linux, another one that's Windows, and then try out your application on there. If it works totally fine, you're like, yes, I'm good to go. We can deploy it. It's good on all these different operating systems or machines. You can also use it to run your applications. You know, sometimes applications prefer running or run better on one operating system than the other. You can use it to host that application. If you have your data center, you might decide that you want to extend your data center to be able to use all these other resources, or you can use it for disaster recovery. You know, if your system goes down on premises, you might still have some data or resources backed up on a virtual machine, and your clients can still have their continuity of their business going on. Does that make sense? So that's the basics. That's the basics of virtual machines. But we're going to dive a little bit deeper. And if I'm going too fast, please slow me down. If you don't understand anything, stop me and I'll go deeper to explain. So next up is Azure Virtual Desktop. Azure Virtual Desktop is pretty much just an application that has virtualized the Windows environment. Okay, so rather than having a Windows machine to be able to use Windows, you can use even a cell phone, you can use a tablet, you can use a Mac, any machine whatsoever. You can even use a browser and to be able to use Windows in the cloud. So in this case, Windows 10, Windows 11, you can even set it up to have multiple concurrent users. So this is something that companies are using quite often now. Why are they doing it? Because you don't need somebody to sit at a desk and start saving their information on there or save information on their personal device, which might have proprietary information on there that might be problematic if someone wants into it. So they just set up this Windows, or should I say virtual desktop, which you can use across any device. You can use across any operating system, and you can still get your work done. They'll grant you access, they'll grant you the right privileges, and give you every documentation that you need. You can still use Windows, or should I say all the applications that run on Windows, Word, Excel, Outlook, whatever you use, it should work just fine. Okay, does that make sense? So that's one way that you can use a virtualization, or you can use your compute services. So instead of having Windows Server deploying to each machine, you have Windows Virtual Cloud. All the data is stored in the cloud. Everything, the application is stored in the cloud. Everything is stored in the cloud. All you do is you just need an internet, you network to it, and then you have access to that virtual desktop. So remember, virtual desktop, it's like a desktop sitting on your desk, but it's virtually. You request that, you get access to it, rather than virtual machine. Virtual machine has its own dedicated resources, but virtual desktop has the whole desktop available on the cloud. You just go ahead, connect to it, and you can use it as you need it. All right. Next up is containers. This is a fun one. Okay. So you might want to pay attention to this. So before, we had just a single computer. Then you get that computer to be able to have virtual machines within it. All those virtual machines, each one of the virtual machines has its own dedicated operating system. We've talked about hardware and software. We've talked about operating system that's linking the hardware and the software. So software, again, another name for software is application. Okay, we use it interchangeably. There are subtle differences between application, software, and program, but in this case, I'm going to use it interchangeably. With containers, containers all sit on top of the same operating system. What we looked at earlier, virtual machines have all this hardware. That hardware sits on a hypervisor, and the hypervisor has different operating systems. Operating systems for Windows, for Linux, for Mac or Android. And then you have all the applications, the files that you need to run the applications and so on. They are sitting on that. For a container, they figured out that let's just package everything in a container. So think about this hypervisor like a ship sailing in the ocean. In that ship sailing in the ocean, you have separate operating systems sitting on it. Rather than having that, you have, in this case, the operating system sitting on it, and then you have a container engine with multiple containers in there. So a container just has whatever is packaged for that application. It does not carry the operating system. The operating system is bulky, it's heavy load taking up all that resources. It's difficult for you to execute or run that application because it has to load up the whole operating system. But in the case of a container, it is lightweight because that operating system is no longer packaged in there. This one container, 2 containers, and 3 containers are separate, sitting on the container engine. Okay, so you can create it, you can scale it out, as we have been talking about scaling, and so on and so forth. So like a virtual machine, it runs on a single host, the same infrastructure, a single machine. But each virtual machine has its own operating system, and it's your job for you to update it, manage it, and so on. But for all the containers use one operating system. They don't bother about managing anything on there. They just focus on their containerization. Okay, so that container sits on this container engine, and this container engine is known as Docker. Docker is one example. I don't know, has anyone here heard about Docker? I think everybody is on mute, but Mr. Adolf has a thumbs on. I think Egbe mentioned about Docker earlier, so I was hoping that this will clarify for him. But Docker in itself is a play of words. Docker actually means dock worker, the person that works on a shipyard, right? Or the shipyard is usually called a dock. So a dock worker is a docker per se. So again, these containers are being loaded onto this operating system by the Docker. So that's how you use it to remember. But now, when do you want to use containers? The better way of doing things in computer science nowadays, or in programming, is breaking up big applications that used to be like skyscrapers. They're known as monoliths. They're difficult to manage. So for instance, if you build an application, let's say this is an application that was built, and then you decided that on top of this application, you want to grow it, you want to improve it, you go ahead and make another part of the application that is an extension. After the extension, you go ahead and add another part that is not really well integrated. As you can see, things start breaking apart. So now, in future, today and in future, things are being done using microservices, as you see on here. Let me get this mouse. As you can see on here, with containers, you use microservices. What are microservices? Now you have all the pieces separated together. Before, let's say you want to create a website, you have front end, back end, and the database, everything all in one. If you want to make changes to the database, it's going to affect everything at one time. If you want to make changes to the back end, it affects everything at one time. But with microservices, you get these services and expand them so that they interact with one another. You can make changes to the front end separately, make changes to the back end separately, make changes to your database separately without affecting all the other parts. So microservices architecture is something that's really good, and it also works very well with an agile environment. That's something that if you're getting into DevOps, we're going to talk more about it, but mostly developers are now developing towards microservices rather than shutting down the entire monolith to build it back up. One service, if you take it down, every other service is running just fine. One service, you take it down, everything else is running just fine. But when you have everything in a monolith, you cannot take down one service, everything will go down. Does that make sense?
Yeah. That makes sense.
Awesome. So yes, we'll talk more about it again in future, but that's what the Docker is, like a dock worker. It helps with this containerization, and you're able to use containers and microservices. Just remember the description. You don't need to memorize any of this. If you can have that picture in your head, you should be able to answer most of the multiple choice questions that will come your way. All right, let's carry on. The next is Azure Functions. Azure Functions, you always see this. If you see serverless anywhere, on Azure or in your assessment or your finals or in your certification, just know it's Azure functions. Azure functions, what are they? They are driven by events. They are known as serverless computer options or compute options. Even though it says serverless, of course, servers are involved, but you don't have to manage them. What are servers? Servers are all the pieces that make up, that are put together in a data center, right? Virtual machine would be a server, virtual desktop a server, container, they are all involved in servers. But in this case of Azure function, the function is actually not going to, is actually what triggers, or an event triggers a function to actually create that resource for you. In the case of a container, the container has to be running or not running. In the case of a virtual machine, the virtual machine either has to be running or not. But with Azure functions, nothing is running. An event actually wakes up the function, and you're only charged for the time that that function runs. You're not charged for the entire time that your server is online. Okay. So what are the benefits in this case? Your developer is only going to concentrate on their code. They don't have to concentrate about building a virtual machine or building all of that. They just know that, hey, my code is going to run. When my code runs, this service runs. And the function is going to depend on a particular event, or maybe a timer on the calendar or a schedule, or maybe a message from another application or a message from another service is going to kick it off. And how long does it run? It's usually a millisecond. Okay. It completes very quickly, in a second or less, everything is done. And there are multiple types of functions. There are functions that don't really track your state. That is stateless. That's the default. But there are other functions that are durable. They actually track the last time the function ran, the next time it will run, and so on. So that's a minor difference between the two. Nothing major. So Azure functions, again, remember, it has to do with serverless cloud computing. That said, there are other options. Rather than just using virtual machines or containers, you can also host your applications or your software using one of these app services, either web applications or API applications. API stands for Application Programming Interface. We talked about interfaces before, hardware and software interface to graphical user interface or command line interface. But when you have software and software, when you have application and application, the two applications talk to each other using application programming interface. Okay. So for instance, you have an application that is WhatsApp. WhatsApp is able to have smiley faces because it's using an API from the smiley faces application. So that it's just using that API, you can use all the smiley faces that you need. The same way GIFs, all these funny pictures and animated pictures, they are all interacting with one application to the other using APIs, application programming interface. You can also use web jobs. Web jobs, again, just like your print jobs, they are just triggers or particular events that get to run, or applications that run on a particular trigger that you get to set. And you have mobile applications that has to do with iOS and Android, depending on what type of phone you're using. Okay. So the benefits of hosting your applications on app services is most of those benefits that we always talk about when we talk about cloud computing. You get to integrate your deployment and management. You don't have to go and deploy. Deployment means you sit and program your application, you build your application, and then you package it and make it available for everybody to use it. So it's deployed to the universe or to the world. Okay, and then there's the security. You create endpoints. Endpoints, again, are the areas that connect each one of these. We'll talk about endpoints tomorrow when we talk of networks. And then scalability. We've talked about scalability multiple times. By now, it's going to become second nature. Everybody's going to remember. Availability, high availability. We've talked about that. Load balancing, we talked about it. But to remind you, if you go out to check out after you've bought something from the store and there's just one line, everybody is going to stay in that store forever. But in order for you to balance the load, you open more checkout cashiers, and then now people can go and you have 4 lines, 5 lines. That's load balancing. Just like instead of having one server or one virtual machine, you can have 5 virtual machines, and the cloud is going to be able to, well, I say the cloud, Azure cloud in this case, is going to be able to direct traffic, manage the traffic to say, okay, there's room for you to go here, go to number 1, go to number 3, go to number 7. This one is available, go here, so that everything works faster, and then there's high availability. Nobody is standing and waiting in line because people are always available, or resources are available for us. Okay, so that has to do with application web hosting. Again, I had to run through this, but another code for you before. I think this is an old code. We looked at this one before. Yes, technology is anything that wasn't around when you were born. We need to update this code, so we'll get a better code next class. Okay, but that's about it for compute services. There are a lot more compute services. When you go on there and search, you would see, and you'll also be able to understand this better. But at the end of the day, we have been able to talk about virtual machines. We talked about containers. We talked about functions. We're able to describe the different options for virtual machines, be it scale sets, be it availability sets, and also virtual desktop. And we talked about the resources that are required for a virtual machine: the RAM, the disk, and the network. Finally, we just talked about web applications, which you can use to host any of your applications. So with that, I'm going to see if you have any questions for me. Let me know. I'll try to answer them. Otherwise, you can always reach out to me to ask your questions. And that is all we have for the day. Yes, Mr. Tibato.
Yes, sir. Like you talk of containerization on sitting on one machine, so on one operating system. Does it mean that with containerization, can you still build? Can they run Linux, Unix, or Windows operating system from that one system, or you need to, if you want to run a Linux machine, you gotta get another container for Linux machine only, Unix machine use Unix only, and Windows when you have Windows only?
Very, very good question. So let me see if I understand clearly. So in here is our operating system. We are saying that this operating system is Linux, but we have these 3 containers on there. Now your question is, can we still go ahead and create a virtual machine in there? Is that what you mean?
Can we run different operating? Can we, yeah, like from those three operating those binary files over there? Can we run different operating systems on them?
Okay, so the reason here, yes, you can always decide and say, on this operating system, I would still want to chop off half of the operating system and do something else with it. Now, let's take an example of that land that we had, that huge piece of land that we have decided to allocate some of the land for the school, some of the land for the, the hospital, and some of the land for a restaurant. If you see that that school is becoming very popular, you're going to need more resources for the school. So normally, that was a constraint, that was a problem, that was a challenge that was encountered with virtual machines, because when you run out of space for this application 1, what are you going to do? You're going to have to go and reallocate. It is not really dynamic that way. It's just fixed, because you have fixed and said, this is the amount of size, you cannot cross this boundary. And if you realize that you gave too much space for number 2 needed just 3 gigabytes, you ended up giving it 20 gigabytes. Now you're wasting all that space. So we realize that in order for us to maximize our resources, let's have everything on that operating system, because here you might have the same operating system installed 3 times with each individual application. Rather than having that, let's have one operating system that has all of these. So if I have 5 applications, 3 of them are running on Windows and 2 on Linux, I can go ahead and have two separate systems. Every application that's running on Windows sits on this application, on this operating system. Every application that's running on Linux sits on the other one. Then, as they are sitting on there as containers, is then flexible. So at the end of the day, you only need the number of different operating systems rather than having the number of applications out there. So if you set up a virtual machine that is for Windows, another virtual machine for Linux, all your applications for Windows go here, all your applications for Linux go there. Does that make sense?
Yeah, I'm trying to get it, but then how does the container engine function from the operating system?
Oh, the container engine functions just like the hypervisor. The container engine just sits on top and manages everything. Okay, so you don't need multiple container engines. You need just one container engine. Let me see if I can paint a picture here in this example. So let's say this is, oh, that's a very big color. Let's use this. So this is our hardware. Okay, the hardware, you're able to get your operating system. On this operating system, you can have in the case of a virtual machine, on top of the hardware, you have your hypervisor. Okay. On top of that hypervisor, you can create operating system 1, operating system 2, and operating system 3. That's because you wanted to have operating system 1, maybe one Microsoft SQL server on there, just a server, another one with a database, another one with a web server. Remember, different servers for different things. So here you have app 1, app 2, and app 3. Every single time you have to allocate resources for each one of those and create more. In the case where you know for sure that you're going to have just 2 different types of operating systems rather than 3, you can go ahead and say, let me highlight this as well. Give it a different color here, something bluish. Let's say this will be your hardware. Now that we've gotten that hardware in there. On the hardware, we decided that we're going to have one operating system. Okay. So in here, you have one operating system. On the operating system, you can also have just your particular Docker. Docker in this case will be container engine. On that container engine, you can then decide to say, this is going to be application 1 and application 2, right? I think I did it wrong in this case. I wanted to break it out to have 2 instead of 1. So let me go ahead and do that again. And this should go there. Okay. So in this case, you have one operating system, which is Windows or Linux, and then you have a separate operating system in here. Oops. Let's make that look nice. So let's just say this is Windows, and that is Linux. You know, app 1 and 2 run on Windows, and app 3 and 4 work on Linux. Now, if you set it that way, you're using this same operating system. These 2 are juggling the use of that operating system. All of that is using this same hardware. For here, if you want to do that, you're allocating hardware for each one of them. Your hardware has to be broken apart to have 1, 2, and 3. Okay, so you have section 1 is going to have this particular RAM or size and so on and so forth. But if you look at the presentation we have here, You don't have to section different parts of your operating system, because this operating system needs a dedicated amount of, say, in this case, disk space, as well as networking, as well as size that it needs. But all of that is being truly shared when it's a container. When you have a container, all of this sits on the same ship. But in the case of a virtual machine, you have one ship, two ships, three ships. Imagine that you want to send 3 cars to Cameroon, and then you have to send 1 car in every ship. That's going to be very tedious and time consuming and takes a lot of money. But instead, those 3 ships are all put in one container and sent using the same ship. Does that make sense? I think you're still on mute, but I think that clarifies it.
Yes.
Awesome. So it depends on how, once you look at it this way, and then you get to work, they ask you, hey, we'll need to deploy this application. The application needs this kind of specification. Okay, it doesn't match what I have here, so I'm going to create a different one to load it up. But before, if you have to deploy an application, you have to go in and create a virtual machine in your server to deploy that application running only on its own operating system. That's taking up resources. Tomorrow, nobody is using the application, you're wasting that resource. Or the next day, everybody wants to use that application, there's not enough sufficient resources, you have to go and make changes. Sounds good?
Yes.
Awesome, awesome. Good. What other questions do we have? We are a little bit over time, and I don't want to keep you guys too much. So I believe.
Another quick question. So
yes,
like Azure admin.
Mm-hmm.
Can you bring up that interface of that this thing? So when I'm talking, I'll be looking at it, the Azure
web portal
interface. Yeah, the portal. So an Azure administrator, does it mean if you're an Azure administrator, this is where you'll be working at and be managing all the applications and resources in Azure?
Very good question. Yes, this is where you'll be working. But like I said, you can either be working in here or you can be using the shell, right? So the cloud shell, this is the front end. Front end has its own benefits and its own drawbacks. If you're using the shell, which is why it's important for us to learn PowerShell or Bash. If you're comfortable using Linux, you probably want to use Bash. If you're comfortable using Microsoft, what do you call it? Not Microsoft. Yes, Windows. Then you want to use, what should I say? PowerShell. As you can see on here, let me drag this to the top. You can easily switch from here using PowerShell to Bash. So in PowerShell, all you need to know is know your commands. If you know your commands, you're fine. For instance, we said there are different sovereign regions for Azure, right?
Yes.
If I want to search for Azure regions, every Azure command in PowerShell starts with AZ. So I've typed AZ, and because I'm using Cloud IntelliSense, what should I say, interactive mode, it's able to give me autocomplete. So I'm saying here Azure Cloud List, I'll put it in a table. If I use tab, it's going to complete it for me. Nope, I guess I lied. If I use the forward arrow, it completes it for me. And then I press enter, it tells me those are the different cloud services. You can see the name here. This is Azure Cloud. This is Azure China Cloud. This is Azure US Government. This is Azure German Cloud. With PowerShell, I can easily identify this. But if I had to go ahead and do it in Azure Portal, I will have a hard time trying to find which button to click where and where and where. So there's more power when you use your PowerShell. There's more power when you use your Bash, because you're going directly to the source to get your answer. It's not like you're outside the egg trying to get in. You're inside the shell and then just going straight to the resource. It's not very colorful, but it's very powerful. Does that help?
Yes.
Awesome. So yeah, as an admin, that's what you'll be doing. You either be writing this, and then with PowerShell, you can decide to write a script. You can say, okay, every morning I have to do this, I have to do that. You write all the commands, save it in a file, come in the morning, just put the file in, it executes, your job is done. You know, if there's an error, it gives you an error that there's a mistake there, you update it, that's it. So for the most part, when you get comfortable writing these commands, you know exactly what needs to do. That's it. Somebody might just call you, hey, we actually want to deploy it just like that application that we did yesterday. You copy the script, you make a few changes, you deploy it, you go about your business, that's it. If they want to back up, you have a script for backup. If they want to deploy, you have a script for deploy. If they need updates, you have a script for update, and then you're good. Because you already know how you're navigating around your Azure environment.
And how is this relating to SQL database? Azure.
SQL database, that depends. If you're going to, again, everything is going to the cloud, right?
Yes.
Before, you had to have your server installed in the on-premises and so on and so forth. With databases, depending on what database you're using, if I go in here and search for database, actually I don't need to search. There's a category right here that says databases. 20. If you use database on premises, you don't have all the benefits that the cloud has. If I have my database here in the basement, the day that there's a flood in the basement, everything is kaput. But if I have my database on the cloud, then I have everything. So all those things that you have, all the databases that you use, whether it's MySQL, there's a version of MySQL on there. Even if it's MongoDB, there's a version of MongoDB. You can get a resource right there. If it's MariaDB, if it's SQL database, all of them are out there. You go ahead and create your database and use it just like that. So if I go into my resources, let's go to resource groups. You can see the example that I did for this subscription. So if you check out that subscription, you see there's a database in here. This database is within this server. So if I click on the server, you can see that within that server, there is a database in there. This is a database in that server. A server, again, is just like a computer machine that doesn't have a display. I can have multiple databases within a server. In this case, I have just one database in the server. As you can see, I'm not currently using it, so it's paused. So I'm not getting charged for this database, even though it's out there. But once I connect to the database, that's when I have to start getting charged for it. So it opens up the database. I can see it to connect. Once I connect, I can now write my query directly from here, and so on and so forth. But to write it, I need to be able to log in and so on and so forth. But those are all the differences. Everything that you can do on premises, you can do it on there. If you're a database administrator, you can do it on the cloud. And you need to be able to understand how the cloud infrastructure is to be able to do it. Does that make sense?
Yes, sir.
Awesome. Everybody is good? No other questions? All right, so let's call it a day, and tomorrow we are going to continue with, I don't have it on there yet, but I'm going to upload it on there. Tomorrow we're going to continue with networking. Networking is what we're going to work on tomorrow. So for now, if you don't have access to Google Classroom, please let me know. I'm going to go ahead and update the notes so you can have a copy of the PowerPoint that was used. Let me go ahead and post that, and then you should be good to go.
Yes, so can you just a reminder, send me the past one for last week so that